Hello and welcome back to our class of soil mechanics. We are still on the chapter number 4, plasticity and structure of soil. So in this video, we will talk about 2 points, the liquidity index and consistency index. For the first point, the second point will be activity. Okay. I think and the next video will be to finish this chapter. So in this video, we will talk about these 2 points, point 5 and point 6. So let's start with the section number 5 of this chapter, liquidity index and consistency index. What is liquidity index? What is consistency index? So we have talked about all these already. What is liquid limit? I hope you know already, you remember. What is plastic limit? I hope you remember that also. And what is shrinkage limit? That was there in the previous video. Okay, so based on this information, based on this parameter of soil, we can establish new parameter. Okay, so liquid limit, you remember that it is the border between plastic state of soil and liquid state. And plastic limit is the lower border of the plastic state of soil. So the border between solids, semi-solid state and plastic state of soil. And the last one we talked about in the previous video, the video before this one, shrinkage limit. So relative consistency of cohesive soil, because always remember that this chapter is mainly for fine soil. So cohesive soil like clay. So the relative consistency of this kind of soil, cohesive soil, in natural state can be defined by a ratio. That ratio is called liquidity index. And the liquidity index can be given by this formula. So liquidity index, Li, is, do you remember what is this one? Water content minus this plastic limit. And the denominator is liquid limit, this one, minus plastic limit. Okay, so this is the formula of liquidity index. And what is liquidity index? This ratio, it is relative consistency of the soil in natural state. Okay, so in city, the water content in city for a sensitive clay may be sometimes greater than the liquid limit. That means sometimes you go in the field, for example, your construction site or any site, construction, a work site, and you find that the amount of water in the soil means the water content maybe is larger than this liquid limit. Okay, larger than LL, this limit, it may be around here. Okay, means the soil is liquid for some sensitive clay. When you enter, for example, in the river, something like that. So in that case, we have the liquidity index higher than 1. Okay, liquidity index is higher than 1 because you will get the water content is greater than liquid limit. Makes sense, right? If water content, this omega or W, If this one is higher than liquid limit, then the numerator of this fraction will be higher than the denominator, okay? Then you will get the liquidity index higher than 1. So if for those kind of soil, if the remolk, they can be transformed into viscous form to flow like liquid, because the water content is higher than the liquid limit. Because liquid limit means once we go above this amount of water content, we enter the liquid state of soil. So the soil become like viscous. Okay. So soil deposits that are heavily over consolidated may have a natural water moisture content less than the plastic limit. Okay, so plastic limit is here, and sometimes we may have less than this plastic limit for this kind of soil. Means soil deposit that are heavily over consolidated. The over consolidation ratio. We will talk about this also, over consolidation, later when we will talk about compaction. So anyway, this kind of soil, sometimes the water content may be less than the plastic limit. This is the plastic limit of soil. And if the water content is less than the plastic limit, it means the soil will be in this state, semi-solid. Okay. So in that case, the liquidity index will be less than 0. Okay, because the water content, this one, is less than plastic limit. This is what say less than the plastic limit. So if this parameter water content is less than the plastic limit, this means that this normally it should be like something small minus something greater. It obviously will be negative, right? That's why we will have the liquid index in that case smaller than 0. Okay, that is the meaning. So another index that is commonly used for engineering purpose is the consistency index, CI. Okay, what is consistency index? So this consistency index is given by this formula: liquid limit minus water content divided by liquid limit minus plasticity index. Okay, do you remember what is plasticity index? This is here. Plasticity index is liquid limit minus plastic limit. I think we have talked about this in the previous videos. Please go and check. So this parameter, if water content is equal to liquid limit, means here, this consistency index will be 0, obviously, because if you have this water content equal to liquid limit, it will be liquid limit minus liquid limit. Then we will have 0, the numerator of this fraction. Okay. And if we have this one, the water content equal to this value, means the plasticity index, the gap between liquid limit and plastic limit. In that case, we will have consistency index equal to 1, because remember that the denominator here is nothing but this plasticity index, liquid limit minus plastic limit. Okay, liquid limit minus plasticity. Actually, this denominator is, let me check, liquid limit minus plasticity index. So if the plasticity index is what water content is equal to plastic, then we will have same here. Sorry. So not the denominator is not plasticity index, but if water content is equal to plasticity index, PI, then we have same thing here. The numerator will be same as the denominator of this fraction. Okay, then we will have liquid limit minus plasticity index, liquid limit minus plasticity index. In that case, this parameter, consistency index, will be 1. Okay, now let's talk about activity. What is activity of soil? So activity is for fine soil, fine grained soil, like clay. Okay, activity is for clay. Soil plasticity is linked to absorb water around clay particle. This is very simple. If I think there are like the plasticity of the soil will depend on the amount of water in the soil. And please remember, when we say soil here, it fine soil, not like gravel or sand. This plasticity, this chapter is for fine soil, clay, for example. Okay, so when we say soil plasticity, actually, so and sometimes when you have mixed sand and clay in this, the soil is mixed sand and clay. Yeah, in that case also, but still the effect is mainly on the clay. So plasticity is linked to the absorbed water around clay particle. Okay, so different, if you have different clay, you will have different behavior. Means that different clay mineral and the proportion affect liquidity index, liquid and plastic limit. So if you have the soil, different types of clay in the soil and different proportion, like 20%, 30%. So this clay mineral will affect the liquid limit and plastic limit of the soil. And we have this skepton that found that plasticity index, the PI, it increases with the clay size fraction, means soil particle smaller than 2 micrometer. Okay, the percentage of this type of soil, that to be maybe clay, for example, clay. So he found out that the plasticity index is rising when the amount, the percentage by weight, please, it by weight, is increasing. The percentage of the clay size particle mean particles that the diameter are really small, smaller than 2 micrometer. Okay. And as you can see, he found different correlation for different type of clay. So we have, for example, this one. I don't know if I can read it right. Is it Horton clay? This one is this type of clay. This one is this type of clay. This one is this type of clay. So the correlation is changing. You can see that they don't have the same slope. But still, the percentage of clay size fraction and plasticity index, we can see that when the percentage of clay size fraction is increasing, the plasticity index also is increasing. So that was a very good discovery or finding. And then he introduces the slope. He introduces something, a new parameter he called activity of clay. Activity of clay. What is activity of clay? It is just the slope of these lines. Okay, the slope. This is activity of clay. So activity is, because slope is this, the y-axis divided by x-axis. So plastic index divided by a clay size fraction by weight. The amount, the percentage of clay size fraction by weight. That is the activity A. The symbol is A, activity, okay? And this activity is used as an index for identifying the swelling potential of soil. That is telling you how important this the activity is. So when you have clay on your working site, on your construction site, you have to be careful. You need this index, this activity, to see if this clay is dangerous to your foundation, for example. Because if the clay is swelling, it will be heaving and it can lift your foundation. So typical value of the activity of various clay mineral are given in this table, especially here. Okay, different type of clay. So I think this one is the most dangerous, between 1.5 to 7. This one, I think in my class of foundation engineering, the second video, I've talked about this same clay mineral, because this one is swelling very, like, greatly when it enters in contact with water. That's why when you have this type of clay, this type of mineral in your clay, then you have to be careful if you are doing foundation on this type of clay. But anyway, just for your information. So this very important. And this reference also, they wanted to do actually deep digging on this activity, clay activity. And what they did is creating artificially mixture of sand and clay. Okay, they mix them together and try to, by using different proportion, of course, and they try to investigate more investigation to see what is the real influence of on the clay particle or like fine particle on the activity of soil. So they noticed that plasticity index is linked to the clay size fraction linearly, but the problem is it doesn't always start from the origin of. So because of that, they depicted, for example, here, you see this figure, relationship, it's still a relationship between percentage of clay size fraction and plasticity index. And as you can see, it's linear, almost linear. Okay, it's linear because it is the slope of this line that will give us the activity of the soil. Okay, so it's linear, but it's not always here from the origin. The relationship is not always starting from the origin. Okay, this is one example. Please note that these are just the fraction because they are mixing different type of clay with sand. See, sand and clay blends, and the ratios are here, but this is not our objective here is to show you that it doesn't start always at the beginning 0. Here also as well, they saw that say it's starting from around here. Okay, so according to this, they decided that okay, the formula is good, but we have to add something. The same formula of activity, but we need to add something. And this is the thing they added. The C prime, a constant for a given soil. Okay, C prime. Mean that maybe we need to do this, but minus something. You see, percentage of clay size fraction. If we do that, we have to do minus something. Okay, minus the denominator of this fraction. And for the record, for these two cases, the C prime is around 9. You can see from 0 from here to here is around 9. Some people will say 10, but it's okay. This one also as well is 9. Okay, so keep the formula, this formula. Yeah, all this to tell you that all the formula you are using in engineering, they're just coming from research, you know. So that the meaning. Okay, let's continue. So they found that the relationship between plastic index and clay fraction can be represented by two straight lines, because there is possibility that the relationship will pass by the origin. It's also possible that it doesn't pass by the origin. There are two possibilities. So they try to model it like so that to respect the both possibility. Okay, this is only this figure, for example. You see, sometimes it may start from the origin like this from here, but sometimes it starts not from the origin like this. Okay, so this figure is showing line passing through origin, this dashed line, when the size is the clay size fraction is over 40. Do you understand what is the meaning? It means that for this line to pass like here, this origin, the amount of clay size particle need to be around here. Okay. Not exactly 40, but around this value. So this reference, they took that from this finding, they say, okay, we will try to find out from which value exactly we have this line. So they say they derive empirical equation for activity based on these findings. Do you understand how it works? Someone is doing research, stopping at certain level after having enough finding. Another person is continuing from that point. And this is how research works. So this was 1964. And this one is 2007. So they proposed empirical equation for activity based on this finding, where the clay fraction CF is 30% or more. And this is the equation they have proposed. 0.96 multiplied by liquid limit minus 0.26 multiplied by this one CF, clay fraction size, minus 10 and divided by CF again, the clay fraction. Okay, I think that's all. Finish. Thank you very much for your time. See you next time.